For question 10, they've said sec x equals to k, and k is more than 1. That makes sense because your sec graph is going to look like this. There should be more down. You get the idea. This cutoff point is 1, so everything, it should be above 1. That's what they're saying. Part 1, they want us to find cos x. And we're going to use, there's one other thing that they've said. They've said x is obtuse. Therefore, in our class diagram, we can use our knowledge of obtuse in that obtuse means 90 degrees to 180 degrees. And that's this region again. Cos x is the same as 1 over sec x. And sec x equal to k. So that means 1 over sec x would be 1 over k. Therefore, cos x equals to 1 over k. And as it's in this region, cos x is negative in this region, as cos is only positive in C and A. So therefore, it's going to be cos x equals to minus 1 over k. For part B, they're asking us what tan squared x is. And what we're going to do is we're going to use our identities of 1 plus tan squared x equals to sec squared x. Sec x is k, so we're going to write sec x equals to k. So sec squared x equals to k squared. So now we're going to have tan squared x equals to k squared minus 1. We're bringing this 1 over here. And that would be our answer for this question. And for question C, they're asking us for cot x. And we're going to use the answer to our previous question and our knowledge of identities. Cot x is 1 over tan x. And we're going to square root this. Tan squared x equals to k squared minus 1. So tan x equals to square root plus minus, we don't know yet. It's k squared minus 1. The way we're going to find out whether it's positive or negative, we're going to use the class diagram. They said it was obtuse, so it's going to be in this region. Tan is negative in this region, so therefore it's going to be minus root k squared minus 1. They wanted cot x. Cot x is the same as 1 over tan x. Therefore, cot x equals to minus 1 over k squared minus 1. That would be our C part answer. Now for our D part, they want cosec x. And cosec x is going to relate to the cot x over here, using our identity of cosec squared x equals to 1 plus cot squared x. Cosec squared x therefore is going to equal to 1 plus the square of this, which is 1 over k squared minus 1. And then when we add these two together, we're going to need to make the denominator the same. So we're going to times this by k squared minus 1, top and bottom. So now we're going to be left with k squared minus 1, k squared minus 1 plus 1 over k squared minus 1, and then that leaves us with k squared over k squared minus 1. And then they wanted cosec x. We right now have cosec squared x. So cosec x equals to the square root, which is plus or minus k over k squared minus 1 over k squared minus 1, the root of that. To find out whether it's positive or negative, we're going to use our knowledge of the class diagram. Cosec relates to sine. Cosec relates to sine, and sine is positive in the obtuse region. Therefore, it's going to be a positive, which is k over k squared minus 1.